Hi everyone. Today we're going to do Unit 8, Day 4, Density Notes. So I first want you to take a look at the picture here. So there's 3 containers, and it wants to know what can you say about the volume of each. So right now I'm using my color copy, so I don't even know if I can point to anything. But so here's my 3 containers, and if you look at the volume of each, they look to be about the same volume. And then it wants to know which one is denser. So it looks like we have rice in the first container, coffee beans in the second one, and elbow macaroni in the third one. So it wants to know which one is denser. So take a look and think about that. So it looks like number 1 is denser. There's more rice. There's more pieces of rice, grains of rice, for the same amount of volume as compared to the coffee beans or the elbow macaroni. So we would say that container 1 is more dense. Okay, so now I'm going to switch to my boring black and white copy. So what can you say about the volume of each container? They are equal, or they have equal volumes. And which one's denser? Container 1, the rice, because there is more pieces of rice in the same amount of space as the other containers. So that kind of leads into the concept of density. So density is a measure of how closely components are compacted together. It's the amount of substance per square unit. So you can fit much more pieces of rice in one little square unit than you can the coffee beans or the elbow macaroni. So density can also be measured as to how crowded particles are in different materials. For example, gold has a higher density than air because in the same amount of volume, gold would contain more particles. All right, so there is a formula for density. Density, which we're going to use D, is the amount of mass per unit of volume of any given object. So it can be calculated using this following equation. D equals M over V. You can think of mass as the weight. It's pretty much the same as the weight of an object. So this is how density is defined. It's your mass divided by the volume, how much stuff you have in a certain amount of space. So it's the ratio comparing, the weight of something compared to how much space it's in. So you can manipulate this formula. If you were to multiply both sides by V, you get mass equals D times V. If you wanted to solve for volume, you can cross multiply, and volume ends up being mass divided by density. So you don't necessarily have to memorize these formulas because I'm going to teach you how to do density word problems based off just units. But this nice little triangle is an easy way to remember. If you remember how to set this up, D, M, V, kind of looking like this. So if you wanted density, you would cover up density, and then it's mass divided by volume. If you wanted to solve for volume, cover up volume, and it's mass divided by density. If you wanted to solve for the mass, you cover that up, and it's density times volume. So it's just kind of a nice little thing. In the old days, when I had to memorize this, I used to do D equals heart. And if you kind of draw in your fraction bar, there's your M, and there's your V. Isn't that cute? For mass over volume. Density is mass over volume. Kind of looks like a heart. Isn't that cute? Okay, but like I said, you don't really have to memorize this stuff because I am going to teach you how to do it by looking at units. So I've been trying to train you throughout this chapter to look at the units of measurement. So when solving a density problem, it is important to pay attention to units. First, check the density units and make sure all given measurements are in the same units as the density units. This is super important. So first check the density units. And you're going to convert everything into what the density units are. So remember, when you're doing these unit conversions, we multiply by a fraction, and whatever units you start with have to be in the denominator of your next fraction so that they're going to cancel out. All right, so we're going to do one example together. So it says here a sheet of aluminum is 2 millimeters thick, 10 centimeters tall, and 15 centimeters long. So this is going to be represented as a prism. So, I don't know, like a rectangular prism. Maybe draw something like this. Something like that, maybe. So we have 2 millimeters thick, 10 centimeters tall, and 15 centimeters long. It doesn't necessarily it doesn't matter where you put these. How about something like that? All right. So the density, so already I'm hoping you noticed these don't match. They're not all the same units. But what we need to focus on right now is you got to keep reading. The density of the aluminum is 2.70 grams per centimeter cubed. Right here is what we need to pay attention to. I'm hoping you realize when you see centimeters cubed, that's volume. And your volume has to be in centimeters. So that is telling us all of these need to be into centimeters. So, first thing, we have millimeters. We have to turn that into centimeters. So this is our metric system. So I am flipping over my reference sheet. Remember, you need to memorize this. Here's millimeters. We have to go to centimeters. We're going to move 1 decimal to the left. So right now, 2, the decimal is at the end. We're going to move it to the left. So 2 millimeters is going to be 0.2 centimeters. So I'm going to cross out that. So I'm going to be numbering what I'm doing to kind of show you the order I'm solving this problem in. And it would be good if you did the same thing because these are quite involved and there's many steps. So if you number what you're doing, it'll be easier to keep track and keep everything organized. So always first, you're going to check the density units. And it wants it in centimeters cubed. Everything has to be in centimeters. Okay, so that's your first step. Second step is you're going to then find the volume because centimeters cubed is volume. So this thing is a prism. So the volume of a prism, getting it off my reference sheet, capital BH. So this is a rectangular prism. So the volume of a rectangle, you need your length times your width. So we need 15 times 10, and then the height of this is our 0.2. I think I'm going to put that in parentheses because I don't want my multiplication dots to get mixed up with my decimal. All right, so I'm going to type this into the calculator. 15 times 10 times 0.2. All right, so right now the volume is 30, and it is extremely important you have the units. This is all centimeters cubed. All right, so the third step now is you are going to take your volume, 30 centimeters cubed, and we are now going to multiply this by our density. Because we have 2.7 grams per centimeter cubed. The centimeter cubed is in the denominator. Remember what I just said up here? Is that whatever units you start with have to be in the denominator of the next fraction. And so now we're going to put the 2.70 grams over the centimeters cubed. So the centimeters cubed now cancel out. You don't need a density formula. You don't need a mass formula or a volume. You don't need that. You just look at your units. So these cancel out. So now I'm multiplying across 30 times 2.70 gives me 81, and the only units left now are grams. Okay? So now if you keep reading, I now have a weight. Grams is weight. That is the mass of this. Now if you keep reading, it says the cost per pound. All right, per pound. I am in grams. Grams is a unit of weight. Here's all my weight. I need to convert it to pounds. So there's a conversion, pounds to ounces, pounds to kilograms, kilograms to pounds. I like using this one here. I like that formula, or this conversion. So to convert this to pounds, it has to be in kilograms first. All right, so again, metric system. I'm right here in grams. I have to go to kilograms. I have to move this 1, 2, 3 places to the left. All right, so right now, I'm going to convert to kilograms. So 81 grams, here's my decimal. I have to move it 1, 2, 3 places to the left. That is going to equal 0.081 kilograms. Okay? So I'm in kilograms, but I still want to convert that to pounds. So I'm still converting. So this, you can call this step 5 if you want. I'm now going to convert kilograms to pounds. And I'm going to use, right here, 1 kilogram equals 2.2 pounds. 1 kilogram equals 2.2 pounds. All right, so I'm taking my last measurement, 0.018 kilograms, and I'm going to multiply that by my conversion. If kilograms is in the numerator, I need kilograms in the denominator, and I'm changing this to pounds. Now I'm just going to put the numbers where they go. 1 goes with kilograms, 2.2 goes with pounds. So again, kilograms is canceling with kilograms. So we now have 0.081 times 2.2. All right, so this is now 0.1782, and the only units left is pounds. So now we're in pounds. Now, aluminum, the cost per pound is 88 cents. All right, so now I'm going to figure out the cost. So this is our step 6. I am taking my last measurement. All right, I'm in pounds. I'm going to multiply this by, it is 88 cents per pound. Per pound. Pound has to go down here. And now my 88 cents is going in the top per 1 pound. All right, so again, pound cancels with pound. And I'm multiplying across. So I'm taking 0.1782 and multiplying it by 0.88. All right, now, your only units left is money. And I got this number, 0.156816. This is money. Money only has 2 decimal places. Okay, so this is 16 cents. But this is only for one, this is the cost of 1 sheet. All right. This problem wants determine and state the determine and state the cost of the aluminum needed to make 20 sheets. So we're almost done. If it costs 16 cents for 1 sheet, we need to take our 16 cents and now multiply that by 20 because we have 20 sheets. So 0.16 times 20. Now, again, your only units here is money. So this is going to cost $3.20. Money should have 2 decimal places. That's how much it's going to cost you. Okay, so that is how you do a density problem. Keep everything neat and organized and labeled, and you just kind of follow through your units. You have to keep units throughout your problem so that your brain knows where to go. All right, they're long, they're intense, you got to pay attention, you got to be neat, you got to organize everything. I would like you to number your steps. All right, have fun. Bye.